Welcome back to Coding with Kyle. This is episode 4 of the IC Avatar Developer series. In this video, we'll refactor our application once again to use the principal as the key that we store our user profiles under. This will allow us to add access control so that an individual can only update or create their own profile. Alright, now to support authentication in our application, we're going to rely on the principal type that we can import from the base library. The principal will allow us to make sure that we have unique users, and so that each user can only update their own type. We're going to accomplish this by storing in our try here a try of principal to profiles instead of using this incrementing next. Our profile will also contain information of the ID now, which will be of type principal. So each principal gets one profile, and we'll make sure that only someone who is making a call using that principal is able to update their own profile. Now, in terms of our interface, we're going to need to change what we're able to call with by accessing the shared context. Now, this is going to give us access to message.caller, which will be of type principal. So just like that, we have access now to whoever is making this call. We will no longer be using the NAT here, so we can remove the logic there. And now we're going to need to update our system for storing. So let's scroll down to our key system. This assumed that we were sending a NAT across, but instead we're going to be passing a principal. And the hash.hash isn't going to work for type of principal. So instead we're going to use the principal.hash, and that will give us our NAT32 hash of the principal. Now up here, we have profile being passed as an argument, and we've added an ID to our profile. But we don't want someone to be able to pass the ID, or shouldn't be expected to. So what we're actually going to do is distinguish the profile type from a profile update type, where the ID is not required. So now the profile comes in as a profile update. And we can take this user profile, and now this is what we're going to insert. Oh, sorry, user profile. The key now is no longer the profile ID, but it's going to be caller ID, because that is our principal. And the equality checker, we can now use the principal equality checker. So to summarize, we are now going to use a principal as the key in our try, And we've updated our create method to allow the implicit message.caller to be what we use to link the ID of our profile. Now let's go ahead and make the same changes to our other methods. And now we can actually remove the profile ID from our read method. And that'll make it so that only the caller or only the owner is able to read their own profile. We can extend this later once we get into the topic of integrations, but by default, let's start with having profiles be private and only controlled by the owner. Once again, removing the profile ID. And we're inserting now our user profile with the bio and the caller ID. And just like that, we've now updated our application to use principals across the board. Let's deploy our application and see what this looks like. All right, now we can go ahead and create a user. We get back OK. Now the read is simply a call. There's no options being passed. And we get back our user with test user. And we can update and delete just as before. Now this shows us one more thing to be careful about, which is that currently the way that Candid UI works is it uses the default anonymous identity that the JavaScript package gives us for the Dfinity agent. And this anonymous identity is going to be accessible by anyone. It's not private, it's just kind of generic. So we don't want to have an anonymous identity be able to update an avatar because that's meaningless. Anyone could do it, and they'd all just be overwriting each other. So what we're going to do is we're going to add a special case for the anonymous user. And prevent them from being able to create a profile. So here we can reject the anonymous identity. If it matches our anonymous principal, and that will always be a consistent anonymous principal right there. Then we will return an error of not authorized. which we can add to our error lists. Let's reinstall so that we lose the previously created anonymous identity user. Great. And now we reject the ability to create an anonymous identity. We can drop this logic into our subsequent methods, and then we'll wrap up. And now our canister is set up so that we can have authenticated calls to have individual users control their own resources. In the next episode, we will use internet identity and the auth client and agent packages to create a front end that is able to make authenticated calls to our canister.